Hello viewers, welcome to my channel Science to Technology. In today's episode of Expo Explained, we're going to talk about Planet Matte Labs, a material. Hopefully you have watched the on-floor recording, so let's dive deep into the technology. So we are talking about a silica compound. Now why do we call it silica? Glass has silica as primary component, so tada, silica composite. Now the idea here is neither the composite is a new thing nor the glass fiber composite. The idea is the unique combination. So what they are trying to replace is, you have to understand that carbon fiber as a material, it's almost miracle material. It's like, it's very lightweight, it's very stiff, it's very long lasting, very fatigue resistant. It's like, it's GG. It's just that its bank balance is ultra GG. Basically, you have to burn money to try that. So while we have made amazing progress in composite structures, we don't use it. Like, yeah, rockets are made out of it, jumbo jets are made out of it. What about your car? Yeah, no. Supercars, yes. Normal cars? No, they can't. They can't even try to touch it because again, it will become unaffordable. So the idea is, instead of having carbon fiber strands which are expensive, you will have glass fiber which is cheaper. Instead of having epoxy, you're gonna have plastic as a binder. So that will try to reduce the cost enough that it can directly target where we use metal, specifically sheet metals. That's the core aim here, not to replace the high performance carbon fiber, but to replace sheet metal that we use for things like, how many material that you have seen that can directly challenge sheet material? A lot of them. Why we are still using sheet metal? Is cheap. Like, why corrugated roof are made out of sheet metal? It's cheap. So this company is directly targeting on that front. It's like, make a material that is better than sheet metal while being so cost competitive, or almost like, yeah, you should do it, or not doing it would be ill-advised for you, that kind of deal. So that's what they are trying to focus on, and their focus is transportation and shipping. That's the key aspect. Why? Weight saving that you're going to gain from here will directly have what we call compound variable, as in, if your truck becomes 50% lighter, I'm talking about the dead load of the truck itself, not the payload you load onto it, just the truck itself becomes 50% lighter, it directly translates into less fuel consumption, which directly helps you with higher ROI. So there is a reason. They are not targeting to make the most high performance material, but they are targeting to make a material that can replace the sheet metal that we do not touch because it's like, cheap enough to compete. Physics, engineering, economics. They are firing missile at economics layer. So question is why? Well, carbon fiber is one of the best composite. Duh. But it's not suited for, the moment you reduce the cost, carbon fiber disappears. It's like, nope, carbon fiber noopes out of there. So why is that? Well, raw material itself is too costly. For example, to spin up a carbon fiber strand, the actual thread, yeah, it's expensive. Like, the strand itself is expensive, and it's not even mass produced. Like, yes, it's mass produced, but it's not like, oh, every country has that. Like steel, every country manufactures it. Carbon fiber, only few does that. And like really high quality one that you can utilize for jumbo jets, yeah. That's like, yo, only few people can even attempt. That's how expensive it is. And it's like 5x higher costlier than the glass fiber. And that's just the fiber. After that, epoxy is also not cheap, and even the amount of epoxy is utilizing this sort of things, it cost, increases the cost. So far, okay, it's just two materials goes together, both are expensive. Yeah, then it has the booster cost, which is slow. Why that is the booster cost? Well, that simply means if you are making a jumbo jet factory, either you have to make a super large factory so you can parallelize construction, because again, making the carbon fiber shell, then laying epoxy, then binding it again, yeah, that will take time. Like, it will take time, like weeks to months will take time, like just to do one part. Like, we cannot do that with cars. Cars are like, sheet metal comes into the morning, by afternoon that same sheet metal has been like cut, stamped, folded, and then welded, and then painted, and tada, it's a car metal. Like, done sir, car, take it and go. You can't do that with carbon, because again, that's the most expensive part, time. You can buy expensive material, BOM cost you can handle with expensive stuff. You can't handle slow stuff. Because again, if you have to have high supply rate, your car factory will become like exponentially larger in order to maintain the same throughput that it does right now. So that's why carbon fiber cars that are like actually done is F1 grade, supercar grade. It's like, it's expensive. Sheet metal can be shaped in a minute. That's your baseline. That's what you are going against, especially in low cost scenario. Sheet metal, bam, done. So you are going against that. So comparatively speaking, carbon composite can take few days. And again, a certain epoxy cures, like for quality control, yeah, it takes a sweet time. Like, relax, chillax. Oh, and not to mention, if you have to use this autoclave, which is a basically high pressure cooker, yeah, it's a brutal. Not only you have to put something, and the structure is idiotically expensive, you have to seal it up, pressurize the hell out of it, and then heat it up at the same time. Yeah. So you can understand that, like, it's not just the raw material that goes into the material that is expensive, but the whole procedure is so expensive. It can be done for rockets, it can be done for supercars, it can be done for aircrafts. Anything lower than that is like, yeah, you're not gonna have your, like, carbon fiber, like actual proper carbon fiber sheet roof shingles. Yeah, it's not happening. So that's the whole point. Mass production can't afford this sort of thing. Like, we use carbon fiber, it's amazing for many things. It's just that, yeah, we can't afford it. So this company's USP is very simple. Enough benefit over sheet metal, not against, like, it's a better replacement than carbon fiber. No, above sheet metal, basically the sheet metal we utilize to justify the mild cost increase. The cost they are targeting is, or they have already brought into the market, $2.5 to $3.5 per kg. Now, is that cost very close to sheet metal? It's a bit up, but not too much. Not too much. That's the whole point. Not so expensive that people will like, lol, I'm not gonna use it. With enough benefit that is like, yo, it's like buying a better tool because it will improve your yield or improve your ROI. So that's the whole point. And because it's a composite, you can tailor the product to based on the customer requirement. Basically, you have a lot of variables that you can tune. You can make it stiff, strength, weight, all these variables you can control. Basically, if it's like, hey, I want the base of the container to be flexible, because again, people keep dropping things into it. You may want a bit of a give there. It's like, I can take it, so it does not damage the supporting structure. Because again, even if the structure itself can handle it, the damage will go through the whole chassis, damaging the chassis. So you're like, hey, it's like, so that sort of tweaking is possible with composite material, and enough weight reduction. This is the critical aspect. Weight reduction to matter. What does it mean to matter? For example, let's just say you have a logistics company and your truck cabin made out of aluminum is X weight. This company comes along, is like, okay, we can reduce from aluminum to, like, let's say 40%. Aluminum, yes, aluminum 40%. And if it's like steel, you can reduce like by 4x. So you can reduce weight. And does that mean you can save fuel? Yes. So it's not like 1% weight saving or 5% weight saving. It's significant enough to matter. That's why I like weight reduction, that matters. And so far, okay, but where's this puppy really shines, especially for places that have monsoon, rain, India, or coast, zero corrosion. This is one of the hidden benefits of composite. Composite can last a very long time simply because there is not that much that actually damages it. Salt, it does not care. Like, boat people love glass fiber. Like, glass fiber, boat love making. Corrosion is like, bro, it can go through seawater, and it's like, if you have something interesting, then talk to me. Like, it does not care. So it's a very corrosion resistant. And it's not like, okay, you have coating and painting. No, no, no. It itself is corrosion resistant. And it's strong also, fatigue wise also. So that's the aim. Replace the sheet metal that we utilize in our day-to-day life with a composite material that is light enough to justify the cost and has enough benefits that it makes sense to do so. Not just like, oh, it's a bit lighter. No, no, no. It has other things. For example, strength. Basically, of course, composite will have better strength, characteristic, low density, that is the weight part, and flame retardant, that's the weak link. Let that be clear. That is the weak link. That looks okay if you're comparing it to aluminum, does not look okay if you compare it to steel. That's the weak part. So what are the pros and cons of this puppy? Well, composite, it's strong. It's not what we classify as isotropic. It's non-isotropic, meaning the directionality of the grains matter. It's almost like wood. So if you're like, hey, I need a plate that has to be like strong in all direction, of course you have to talk to them, and they're like, okay, we're gonna have one layer like this, another 45 degree, another 45 degree, and another 45 degree. That way they can make a sheet that behaves like absolutely like a sheet metal. So it does require you to, tailor made for you. That's the pros and cons itself, meaning you can tailor made it to you. Penalty, you have to tailor make it. It's not like sheet metal, just buy and do whatever you want to do with it. So that is like, double-edged sword, but stronger than aluminum. And steel is like, it's not even a competition against steel. And lightweight and fatigue resistance. This is a critical aspect of composite. If done correctly, composite can handle this sort of thing, meaning if you're flexing, expanding, flexing, it gets bent and over time it damages. Aluminum is really bad in this, and steel, while it is bit better, it's still not like, don't worry about it. So that is a very critical part, meaning if you build a structure out of it, how much you can put your faith into it, composite will outlast it. Like composite will flat out outlast it, and its failure is far more what you call predictable. So fatigue resistance is much higher, meaning you can abuse this puppy for years and still have something robust. Do not abuse puppies. So it's made for mass production. So basically they have the mat and they put it in injection mold and put thermoplastic into it. That's what they are doing. Now, of course, what exactly is the special sauce in the thermoplastic? What is the coating for the glass fibers? Yeah, those are special sauce part, but inherently that's the whole idea. And long fiber, not chopped fiber. There are thermoplastics that are available in the market used in tool makings that generally have glass fibers inside the plastic. It works, it's a bit better, but it's not really that useful because it's not a composite material. It's just a material with different property. Composite requires the whole strand to be there, not just like 5mm strands. No, whole structure has to be there. So compared to chopped fiber pallets, it's definitely better. Now, the weak link is weak against fire. Not against aluminum, simply because while aluminum itself can handle a lot of fire, it becomes weak very early on, like 300 to 400 degrees Celsius starts to become weak, meaning if there is any load on it, it will crumble. Like that happened with the LA forest fires. It's like, why my wheel rim melted? It's like, it did not melt because of the temperature, it was under pressure. The car weight was under pressure. You heat it up to 600 degrees Celsius, like, it will deform. Not even 600, 450, it will start to deform. Aluminum is really not that good if you are heating it up. Steel can handle it, but even that will, especially if under load, even at 400 to 800 degrees Celsius, it will like, yeah. Basically, structural integrity gets compromised. So fire resistance is not that great. What does that mean? That simply means in the thermoplastic, they have to add additives. Those additives are charring additives, meaning when they burn, they create a charcoal layer kind of structure that acts as an insulator. So it does not allow it to burn on fire. It just creates a barrier. Now, will it be as robust as steel? No, of course not. But it's not like, one matchstick and boom, it will not happen there. But it is weak against that. And UV also requires some additives. Because again, they want to make it sure it's white for insulation reasons. They cannot rely on carbon black. That is one of the best what we call UV additives that we do. So they have to use some fancy compounds, but it can be done. So these are the weak links. Like again, almost everything else I can trust and it makes sense to replace it. But that fire weakness is like, meaning if I'm shipping an electric vehicle with lithium cobalt manganese batteries, I will be like, yeah. So there are pros and cons to this. Like in most scenario, it will flat out be awesome. The only scenario where it's like, is fire. So what can we expect in the future? Well, because again, they are directly trying to replace that puppy as in shipping containers. It does require what we classify as long-term field test, meaning actually put it in a ship, sail it across the 7 oceans. So yeah, that could require like, 5 to 15 years. So yeah, that has to be done because again, everything works in lab, everything works in accelerated testing. It's just when you do it in real life, it's like lol. So we want to make sure that lol does not happen. And there are benefits that makes it worthwhile. Like weight reduction of a shipping container ship on a truck matters enough, and not to mention you can have double dipping, meaning if you reduce the weight of the system and you know that the container is lighter, you can add that much extra weight in the payload, so you can double dip. That is possible. And not requiring paint. Paint is optional. You can do that for decoration, but you do not need to. That's why they are specifically focusing on white polymers. The idea is it will reflect enough heat, so things that are inside will not degrade. And if you have to insulate for refrigerated container, it would be much easier to do so. And thermal conduction is also much, much resistant. So compared to metal that boils, this will last much longer, which again, for many of the shipping containers have refrigerated unit, it will be like shut out, take money. Because if the original material itself does not boil, the insulation can do their job far more effectively, and the AC unit that is on the container itself will last much longer, as in consume less fuel. So it does have benefits that justify it. No pain, and the biggest part is for an electric vehicle, it will have very good impact. Not on basically combustion engine. Combustion engine does not like to be partially loaded. Look into any engine that you buy, BSFC graph, it will always, if you reduce the load, as in like the torque loading required, it actually burns more fuel. So there is a sweet spot. Anything below or above, it does not like it. So your fuel saving will not be that whoa that it should be. But on battery, it will be like, whoa, why the heck I'm getting so much advantage? You will get advantage. Basically, in fuel, it's decent. In electric, it's like, whoa. Because again, electric motor is almost similar level of efficiency at same all speed and all torque loading within its range. So that's the whole point. And to give you a context, what sort of weight saving we are talking about, let's say these puppies, that can easily carry 15,000 shipping containers, that is 40 feet in unit. 40-foot containers, standard shipping container. Yeah, if you replace all the steel one with this one, you're looking at 30,000 ton of mass reduction. That much mass reduction is cheap. That is like, they will be like, hey, we are burning less, what we call bunker oil. That's how big impact it would be like. Because be mindful, those engines can keep working for 2 weeks. And if you are 30,000 ton lighter, so it does matter. So, and again, I'm happy that not every Tom, Dick and Harry is like focused on like, what if I replace the best material with even better material? It's like, this is directly focusing on something that is like, we do not try to replace it, because like, can we really make something that cheap? They're like, what if we tried? So I wish all the best to Planet Materials have. Again, let's just see how it unfolds. But again, corrosion proof really matters. Really matters, like especially for salty things. Ooh, that's the most, I'm pretty sure if they can match the lifespan, does not even need to extend the lifespan. Like, oh, steel one lasts 10 years, after that you have to do servicing and all that, or throw it away. This you can again do the same thing, 10 years and throw it away. Just because it can handle corrosion far better, people are like, yeah, I'm buying that. So, assuming all other testing, real world testing proves that it is really worth it. So I'm happy that this is clever use, very clever. So this was my presentation on why somebody would want to have like Silica Composite. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.